Yeah, hi guys, good evening. Good evening. Let me know if I am audible, I am visible after a long time. So let me know if all is good. Good evening, everyone. Why don't you guys just put something in the chat? Good evening, everybody. Yeah, somebody's in the chat. Why don't you confirm that in the chat that the audio is clear? You're able to hear me out. The audio videos are clear. And it's been some time, so I was with you. So I hope all of you guys are doing good. Yeah, hi Shristri, hi Tanuj, hi Ankit. All good, very nice. Nice to be with you guys this evening. Very nice. Good. So, how's your cat prep? Hi Isha, hello. Yeah. So how the things? How's your cat prep going on? It's been quite some time. Yeah, Keval, glad to see you. I'm fine now. I'm fine. Thank you. Yeah, good, very good. Nice to get some response from you guys. That's brilliant. Yeah. Okay, all right. So let's get to the proceedings. Maybe we'll spend some time on the chat or maybe at the end of the lecture. Hey, hi Rishav. Good evening. Good evening. Okay, that's good, Cable. That's good. Just started with PNC module, all right. Hmm. Okay. So, but we are already doing reinforcement here. Okay. Interesting. Is the audio clear? Can you guys just confirm me on the audio? Is the audio clear? Is the audio clear? Because after a long time I did few settings here and there because didn't use the system for some time. So audio clear? Am I clearly audible? No background noise, nothing, right? Good, good. All right, okay, so good. Hmm. Yeah, fine cable. All right, superb, superb. No issues, no issues. All right, guys, let's get started. Let me quickly introduce myself. If there is anybody new going to watch it at some time in time, otherwise, I'm quite familiar to you. So, just in case somebody is not familiar, I'm Belvi Srinivas. I've been working in this industry since 2007. That's about 14 years now. So, in that 14 years, I did work on various things. One on the content as well as on the management side of it. So that's designing the course, curriculum, etc in various capacities in different organizations, and I did develop some skills to train students, especially in the areas of QA, DI, and LR in that period of 14 years of time. That's briefly about me. And yes, if you'd like to get the notifications or would like to have short discussions or you would like to rectify some of your doubts, you can join this particular Telegram group. Not only I, there are several other good students who are willing to help each other are also on the Telegram group. You can take help from each other and we can have short discussions on this. Yeah, quick announcements before we unleash ourselves into the lecture. So as all of you know, Unacademy offers two kinds of programs, two kinds of subscription plans. One we call it as Plus, the other one is Icon. On the Plus, you get the kind of the structured courses, that is different programs. The courses are designed for different programs. Maybe some of them are designed keeping SNAP in mind, some of them are designed keeping IIFT in mind, keeping NMAT in mind. Different difficulty levels, the different courses with the kind of relevant background would be taught with respect to that course. So one on the YouTube, at times we'll be doing it generic, and specific all it would be done all it technically on the subscriptions. That's on the Plus platform. Right, so that comes with some of study material, your weekly test, etc., etc. And Iconic, in addition to whatever we said in the Plus, Iconic gives you the it facilitates you to speak one-to-one with the mentors of your choice. So you can set the meetings, and in those short meetings you can discuss your test plan, you can discuss your study plan, you can discuss your interview questions. Some of the interview questions, if you are not clear, you are not certain, you can seek guidance with respect to that, and various other things. Whatever you have, you can be with respect to concepts, the doubts, all that can be, you can set up the meetings and you can take up those discussions on the Iconic platform. Yes, now these are some of the programs that are upcoming programs. That's today. There are a couple of launches, some of them for CAT 22, I'm sure most of you would be looking here for CAT 21. If you're looking at CAT 21, and if you're also looking at IIFT as one of the courses, probably you can also look at these particular courses. And specifically here, I'm doing the algebra on this particular course. I'm going to deal with algebra for several hours on this particular course, with the other educators having different agenda. Those who are on the plus, you would know how you can understand what people are trying to do out there. Yeah, so this is what I think is either the plus for 6 months, or it can be the iconic for the 6 months, could be the one of the plans that you could be looking for. If you're also looking the help for the interview perspectives, in the sense like, because as you go along, you know that there will be a couple of tedious questions which would be asked in the interview, some of the subjects that you got to brush up. What can be the subjects from your perspective? You are looking for all such guidance in addition to the test, because test is just about 1 or 2 months. After that, you may need another 2 or 3 months from that perspective as well. So you can go for about 6 months. Not 6 months is too high, then you can go for 2 month plans and 3 months plans. Various other plans are there. So on all these subscription amount that is mentioned here, you get 10% discount. You get 10% discount if you use any of the educator code, including my code, right? Including my code. Yes, so this I recommend, guys. I said that on every weekend, that is on Sundays, I said that take a test, right? Every Sunday, take a test. I think here is a golden opportunity. I would like you to at least take these tests on Sunday starting tomorrow. 17th one Sunday, 24th the other Sunday, 31st is a Sunday, then 7th November is Sunday. On all these days between 12:30 to 2:30, there is a free mock, free full-length mock given by is been facilitated by the Unacademy. I would rather suggest at least take these 4 tests, and in case it asks for a code for subscription, you can use my code, or any educator code for that matter, you can use to subscribe there. So I would like you to take these 4 tests. Okay, if you are already taking some tests, you don't have time for these 4 tests, taking 2 tests on a given day does not make sense. So but then, like, if you are willing to take these particular tests, the other tests you can take it, you can increase it to, because from the November onwards or mid of this, you can increase it to 3 tests per week, right? You can increase it to 3 tests per week. You can say that, hey, on Sundays I will take this particular test, but don't take 2 tests on any given day. All right, mind you. So if you are thinking that no, I will take 2 tests on a given day, never do that mistake. You should be at your best before writing the test. So I told in one of my strategy videos as well, 2 or 3 tests, at least in the November, you must be writing 3 tests per week. So it's okay, towards the fag end of October itself, you can get on to the 3 tests per week if your preparation is already kind of up to date, kind of like, you did significant preparation. So you can do about 3 tests per week. That should not be a concern. So if you're doing 3 tests per week, so one of them would be a week's beginning. That's a Sunday, you can take one. Leave Monday gap. You can take one of them either on Tuesday or Wednesday. Leave Thursday gap. All right, now, so if you're taking on Tuesday, it could be a Thursday. If you're taking on Wednesday, it could be a Friday, right? Something like that. You can kind of plan it. You can plan it how you want to navigate this, but at least leave a day's gap between the tests so that you kind of introspect. You spend some time as to how you want to approach your next test. It's first, it has to be one in the mind. You can't approach the test without winning it first in the mind, kind of it. At least mind victory is important. Do we really win the test or not? That I'm not sure, but at least have that winning attitude in the mind before you approach the test. Therefore, I clearly say that no 2 tests on a given day. Fair enough. All right, so that brings us to the closure of the discussion. Quickly let me know who are all with me, who are all joined in. I think because it's not updating, I guess my YouTube is not updating. Just let me know who are all there quickly once. Let's quickly exchange some greetings and get started. Yes, guys, am I audible? Am I visible? Why don't we quickly exchange few greetings and get started on that note? Karthik, no counseling here, Karthik. Okay, counseling can be done offline. Okay, yeah. Rishav is there. Sahil, Saurabh, you guys are there? Sahil, Saurabh, you guys are there around? Yeah. Oh, Nazia is here. That's nice. Good. Okay. Glad to see Sahil around. Okay. Gopal. Hi, Gopal. Gopal, your name appears to be little new to me. I'm not sure. Abhishek is fine, but Gopal, are you new here? I mean, like your name appears little new here. Yeah. Yeah, same here, same here, same here, Nazia. I am also excited to be with you guys this evening. Of course, it's been quite some time. Yeah. Yeah, Sahil, true. True. I agree with you. True. Same. Okay, let's get started then. Okay, let's get started then. I think we'll do this reinforcement till the end of when you kind of writing these exams. We'll do that. Okay. All right. Mansi, I'm doing reinforcements, right? So it's for CAT 21. Technically, this particular series, the reinforcement series is for CAT 21. Yeah. Hi, Vikas. Hello. Good. Yeah. Good to see you guys. Some familiar names. Very nice. That's good to see. Okay. So what we were doing, all right, I think like, no, before we kind of concluded, I think this is what we were kind of discussing in PNC. Okay. I'm not doing this problem again. Don't think that I'm not doing this problem once again. It's not about that. So just a recall that because it's been quite some time, just a kind of a recall that, hey, what we are trying to, where we stopped sometime when we were doing this discussion on PNC. Okay, yeah. Because we'll come to the timetable later, 4 and 10. On the YouTube, it is 4 and 10. We will come to those timetable later. Let's go with the discussion before it is late. Yeah, okay. So if you could kind of recall, hey, this is what we kind of done. And because there is an inequality here, we spoke about using a dummy variable. Remember? Anybody remember? Why don't you guys acknowledge? We said that, hey, we can use dummy variable to convert an inequality to equality. Okay, I'm not doing this problem once again. It is already there in one of the videos. You can always go back. This is the CAT question as it is. But we said, hey, if there is an inequality, we can use a dummy variable and then come back and solve it. Other than Rishabh, can somebody also confirm that, yes, you kind of remember this? Now, don't sit and solve this. I'm not asking you to sit and solve this. I'm just saying that, hey, do you remember this? Rishabh says yes. Anybody other than Rishabh who can confirm on this? Okay, Nazia is with me. All right. Yeah, don't sit and solve. In case you have a doubt in this, you can always go back to the video. But at least confirm that, yes, we did something like this. Right, Sahil, good. Yeah. 2015, whatever, correct, all right, good, right, yeah, something like this. Then towards the end of the discussion, we were talking about some identical dice. There was some confusion because people thought that identical, distinct, the answers kind of remain same, but then we kind of reached that particular stage saying, hey, be very careful about the words identical and distinct. Your outcomes change. Total outcomes are different if you roll two identical dice with respect to when two distinct dice, right? So otherwise the outcomes are different. So are you clear on this? So this you kind of recall now? Yes. So we discussed something like this. The outcomes were different. Confirm. Not just Rishabh, Nazi and Sahil. Anybody else? You kind of remember this. Identical dice. The outcomes on identical dice are different from the outcomes on distinct dice. We had a brief discussion towards the end of that particular lecture. Confirm, quickly confirm, friends. Yes, no, you kind of, yeah, we did that. You remember? I kind of remember doing this discussion. Rishabh is the only one who remembers this. Okay, Radhika also remembers. Good. Nazia, you also remember. Good. Anybody else? That's it. Only three of you remember. Sahil, are you there? Saurabh, are you there? You remember this? Okay. Right. Yeah, good. Very good. Yeah, sit on a device, guys, where you can respond, right? Sit on a device. I know sometimes you'd be sitting on mobile and it would become a little difficult to type in, but at least interface, I'll let you know, you put that such that, like, you are kind of able to respond and always stay live. So don't try to go back by 2 minutes, 3 minutes. I ask something, after 3 minutes you respond to it. Stay live. If you miss any portions of lecture, go to it at a later stage. Okay, here comes one of the questions. I will tell you why I'm talking about this, because in CAT, on the probability, we had questions of this particular nature. So we don't do anything which does not appear in any of the exams. We do questions which are relevant. Otherwise, we can learn any of these topics to any extent, right? That I clearly agree, right? So we can learn learn the same topic with respect to IIT JEE perspective, but we are not doing that. We are doing sticking understanding that from the CAT or IIFT or ZAT, assuming that if I prepare for these three exams, other exams also kind of get covered, right? More or less, most of the logic would kind of get covered if I try to speak from the perspective of CAT, ZAT and IIFT. So now I'm coming to a concept question based on this, right? How many ways a sum of 13 can be obtained when 3 dice are rolled? Now again, don't get confused. Whenever it is not identical, I don't have to say that they are distinct. Absence of any quantifier here. Hey, is it identical or is it distinct? It is distinct. I met 3 children, which means I could recognize them. If I now again stand, those 3 children were looking different, right? I saw 2 coins, which means I could recognize them. Both coins were looking little different. Similarly, I rolled 3 dice, which means I could recognize them. They were different. If it is identical, I add a word. Hey, identical. I met 3 children. They were looking identical. I met 3 identically looking children. So I use the word identical provided that is required out there. Otherwise, it means that, hey, I can distinguish between the 3. Now here, when I say that I rolled 3 dice, which means there is a small distinction between them. Maybe the size wise they were different, or the color wise they were different, whatever. I can distinguish between them. It's not that I'm getting confused between the 3 dice. I can distinguish between them. Okay, let's come back to this particular question. In how many ways a sum of 13 can be obtained when 3 dice are rolled? Okay, I will give a minute. I'll give a minute. Think about it. How do you approach this? How do you approach this? Think about a minute. And do you want to put some answer within that minute? Put it there. It doesn't matter. Yeah, think about a minute. We all have a cold start. So that's the reason I'm saying that you start thinking. You start thinking for a minute so that we get out of the problem of that cold start. Go ahead. Everybody go ahead. Just think for a minute. I'm not expecting an answer. If you get an answer, type it. Doesn't get an answer, no worries. Because I have a point to make here. We are learning. Yeah, that's right, Rishabh. That's right. Okay, all right, good thinking, friends. Listen, all of you listen. So we spoke about the lower limit, right? So what is this I'm trying to teach today? So one of the concepts of today, one of the things that I'm trying to teach today is the upper limit, dealing with the upper limit. There was always a lower limit which we dealt. Hey, what is that lower limit that we dealt? For example, we had an equation, let's say that, hey man, x plus y plus z, all it is equal to something like a dozen, it's a 12. The x should be minimum 2, that's a minimum 2. Greater than or equal to 2 means what? Minimum, that's a lower limit. Hey, y should be minimum 3 and z can be minimum 0, which what is that I'm trying to say? I'm trying to put the lower limits for x, y, z, and we dealt with it. All right, we dealt with it. Whenever there is a lower limit, you said that, hey, give the 2 off, give the 3 off for these characters. In the sense you said that, hey, give this 2 to this x, give this minimum 3 to this particular y, and then we said that I can bring it down to 0. Therefore, original condition 3 plus 2 means 5 are withdrawn, this 2 and 3, 5 are gone out, therefore there is a 7. Answer is 9C2, all right, which becomes my answer, which we already kind of dealt. I don't have to reiterate that. My point is what is that I'm trying to say? Hey, we understood the problem of how to deal with the lower limit, but we didn't deal with the problem how to deal with the upper limit. For example, say outcome on the first die is x, the outcome on the second die is y, the outcome on the third die is z. Let's say together it should be equal to 13. This question I am writing, but the point here is, hey, x should lie between, now think about this x, my friend, the x should lie between 1 and 6. X should lie between 1 and 6. There is an upper limit also, right? X should lie between, this is the upper limit. This is suggesting the upper limit, upper bound. It should lie between 1 and 6. I didn't use that here. Here, when I'm talking about x, x should be less than, all it x should be greater than or equal to 2. That's all I said. X should be greater than or equal to 2. Here I'm saying x should be greater than 1. At the same time, x should be less than 6. So what is that we are trying to learn today in the first few minutes is, we are trying to understand that how to deal with the upper limit. If there is a lower limit, we already studied the lower limit. We are trying to deal with the upper limit as well. Let's see this. See, one way, if this question comes in the exam, let's assume that, man, this question came in the exam, I don't know how to deal with the upper limit. Absolutely no problem. Make the cases and deal with it. That is the easier way to deal with this particular question. But yes, then how should I also then know that I should how to work with the upper limit? Yes, you should know that, because for some other questions that is required. If this is the question, should I know the upper limit? I don't have to know the upper limit. The dice 1 gives a value called x, dice 2 gives a value called y, dice 3 gives a value called z. I will simply make I'll make a pattern and deal with this. What is the pattern that you make? Let the value of x be greater than or equal to y, which in turn is greater than or equal to z. To make a pattern, I'm showing this. To make a pattern so that I don't have to be redundant, I don't have to calculate things all back and forth again. So therefore, I'm making a pattern on this. Okay, what is this pattern? The best value x can take is what? 6. The best value. I'm starting again in the pattern. I'm starting from the best outcome on the dice 1 called x. Best outcome on the dice 1. What can be the best outcome so that already it is greater than or equal to 6 again? Z can be 1. 6 plus 1 gives me 13. But this can be permuted in 3 factorial by 2 factorial ways. What do you mean by 3 factorial by 2 factorial? This is the configuration 6, 6, 1. Why 6 should be on the dice 1? 6 need not be on the 6. So why 1 should be on the dice 3? So 1 can be on the dice 1 as well. Correct. All right. Now therefore I say that it can be 1, 6, 6. Or it can be 166. This is what I mean by 3 factorial by 2 factorial permutations are possible on this particular configuration. While writing configuration, I will make this pattern so that I don't have to keep writing 166 is different, 16 these are different. I don't have to write all of them. I would write one pattern and I will say that this can be permuted in 3 ways. Okay, next one, what I do, keep the 6 as it is. I can make this 5 4. Sorry, I can make this 5 2. Keep this 6 as it is. So I'm keeping this first 6 as it is. I'm fixing it the best. So I'm permuting the other two. This was a 6 1. I say that I can make it 5 2. I can make it 4 3. Then you may say that, sir, I will make it 3 4. Not required, because I said that y should be greater than or equal to z. Because if you write this 3 4, that was already here on the top. Therefore, I don't write it. I say that, okay, I will make these 3 patterns. Then I will reduce the value of x. I will make it 5. Then the best value y can take is also 5. 5 plus 5 10. Therefore, this is 3. Now, still keeping this at 5, I can make this 4 plus 4. Okay, that is done. All right, now that is 13. So I will stop the patterns of 5. What if I make it 4? Then the best value this can take is 4. The best value this can take is 4. This adds up to only 12, but I want 13. Not possible. Now I will permute them. This can be permuted in 3 factorial ways. This can be permuted in 3 factorial ways. This can be permuted in 3 factorial by 2 factorial ways. This can be permuted in 3 factorial by 2 factorial ways. Why? Because two numbers are same, therefore by 2 factorial. And then you say that, hey man, this is 6 and this is 6 and this is 3 and this is 3. I add up all these cases, 3 plus 6 plus 6 plus 3 plus 3, which becomes 21, which is nothing but my answer. Okay, give me a confirmation that the pattern method is clear to everybody. This is what is expected, at least this is what is expected out of you, and you take 2 minutes to solve this. 2 minutes to solve this in the exam. If this question would have come, you would have taken 2 minutes to solve this question. Within 2 minutes, this is the information you would have written and you would have solved. Yeah, roughly about 2 minutes. 2 minutes doesn't mean 2 minutes. Plus or minus is always there. I'm not denying that. Around 2 minutes. That's an average time. Confirmed, other than Sahil and Rishabh. Will others also confirm that you followed what I wrote? Or if there is a question here, let me know. What is your concern here? What's a concern? Let me know. If the concern is clear, then it is fine. So why did I do this? Because there is an upper limit also here. Because there is an upper limit as well. So I made a pattern. Pattern is one way of dealing with this. Anybody else confirm here? Other than Sahil and Rishabh? Guys, am I making sense? Or am I making sense only to Sahil and Rishabh here? Okay, good. Nazia joined the party. Okay. Fair enough. All right. At least to three of you, it is making sense. I'm hoping that to others also it's making sense. If not, probably you may have to go back and do it. Now look at this. So how do I resolve this particular issue? One. So first I will do total. What is total? Total is x is greater than or equal to 1. Y is also greater than or equal to 1. Z is also greater than or equal to 1. Why? These are the dice, right? These are the dice. Outcome on dice 1. Outcome on dice 1, outcome on dice 2, and outcome on dice 3 is equal to 12. Let me forget the upper limit because I don't know how to deal with upper limit. Let's say I know only how to deal with the lower limit. What is the lower limit on a dice? 1, because the outcome on the dice are 1 to 6, 1 to 3 up to 6. All right, this is the outcome on the dice. I can't say that dice gives us 0, so there should be at least 1. What is the total? Therefore I cannot solve a question where x, y, z are 1, so technically you will take it down, drag it down, or drag it down to greater than or equal to 0. So therefore you say that if you want to make this greater than or equal to 0, you would have got rid of 3 here, right? You would have gotten rid of 3 here. You would have given 1 to x, you would have given 1 to y, you would have given 1 to z, you would have gotten rid of 3, and you would have made this equation 9. Therefore you say that, hey, total, therefore now this is the total. Total is equal to 11c2. What is 11c2? 11 into 10, that is nothing but 50. 11 into 6, 11 into, am I right? Yeah, 9, 10, 11, 11c2, that is 11 into 10 divided by 2, all right, which is nothing but 55. Your total number of outcomes are 55, right? Yeah. What is 13? Oh, thank you. All right, this was 13. Sure. 13, so 10, 12c2, 66. Okay, now this is total. Now listen carefully here. In this total, listen guys, all of you listen here. In this total, even this result is there. When you took x plus y plus z is equal to 10. X was already given 1, y was already given 1, z was already given 1. I'm illustrating this. Okay, x was already given 1, y was already given 1, z was already given 1. Now this 10. Now it is possible that the entire 10 was given here, 0 here, 0 here, which means the value of x was 11, the value of y would have been 1, the value of z would have been 1. That's a possible case. I'm not denying that it's not a possible case. It's a possible case, but this is not possible on a dice. On a dice, you are trying to say that one of the dice has given me the outcome of 11. Not possible. One of the dice wouldn't have given the outcome of 11, which couldn't have been possible. Then how do I get rid of this? Now get rid of the cases. Now go back to the original equation. Let me go back to the original equation. You can say that I will deal with this equation. That is also fine. I'm saying that, hey, why don't you deal with the original equation? Because that's easier. Every time go back to the original, deal on that. Hey, remove the cases in which x is an example. Again, x is an example. It can be y also, it can be z also. X is an example in which x is greater than or equal to 7. I don't want the cases in which the value of x is greater than or equal to 7. Why? Because the dice can take only up to 6. How it has taken is 7. I don't want the cases in which the value of x was greater than or equal to 7. So other ones, as usual, they could have been 1s. Other ones could have been 1s. Now you may say that, sir, can't it be possible that x is also greater than or equal to 7, y is also greater than or equal to 7? Not possible with the number called 13. With the number 13, that is not possible. X is also greater than 13, y greater than 7, y is also greater than 7, then that should become negative, right? That's not negative. I am saying that, hey, one of the dice called x, let's say one of the dice, say d1, all it has given an output which is greater than 7, which is actually not possible. I'm removing those cases, and the other dice have given the as usual outcome, because only one of the dice can give a greater than 6. You can't say that simultaneously two of the dice will give me output of greater than 7. That's not possible because the outcome is 13. Okay, if that point is clear, now let me answer this particular question. Therefore, how much this would become? Give 7 to this guy, give 7 to this guy, therefore x can be greater than or equal to 0. Give 1 to this guy, therefore y can be greater than or equal to 0. Give 1 to this z, so z also can be greater than or equal to 0. Okay, thereby this becomes, how much did I reduce? 7 and 1 and 1. I'm reducing 9 from here, therefore I have 4. Now find the values to this. 6c2 2, the value of this outcome. Therefore, what is this answer to this particular equation? Answer to this equation is 6c2, which is 6 into 5 divided by 2, which is 15. But the point is, hey, why x could have given me greater than 7? It could be y which could have given me greater than 7. It could be z which could have given me greater than 7. Either x could have given me greater than or equal to 7, or y also could have given me greater than or equal to 7, or z also could have given me greater than or equal to 7. Therefore, into 3, hey, y into 3, I took x as a test case, but same thing is possible for y also, and it is possible for z also. Therefore, I am writing it as 15 into 3. What is 15 into 3? 45. So you are saying that there is a total of 66 cases, out of which 45 are unfavorable. Unfavorable means what? You are saying that the dice can give an outcome of greater than or equal to 7. These are unfavorable. So the required result is 66 minus 45. Hey, what is 66 minus 45? Which is nothing but 21, which is similar to what we discussed before. You understood this now? Did you understand this? The approach is clear to you. If the upper limit is 6, give a value more than upper limit to one of the variables. Give a value of more than upper limit to one of the variables. The dice has an upper limit of 6. What did I do? Alright, what was the method I'm trying to teach? Give a value of more than upper limit to one of the variables and then permute it to other variables also. Permute it to other variables later. Give it to one of the variables to start with. Understood? Method is clear. Is the method clear? If there is an upper limit, how to deal with this? Of course, we can go deeper into this, but at least we should know that how to deal with the upper limit with one variable at least. Guys, other than Rishabh, Sahil, are you following me? What we are trying to do is how to deal with the upper limit. How to deal with the upper limit? Give one of the variables a value greater than upper limit. Give one of the variables a value greater than upper limit. It is sorted. The problem is sorted. Technically, the problem is sorted. And then permute it. Come back and permute it to other variables. Guys, can others also confirm what we are trying to do? I think Sahil and Rishabh are the only two who are following actively. I think Nazia is on a device which she is not able to figure it out. Okay. All right. Why you want to give 8 to x? Greater than 7 means everything is covered, no? Rishabh, when I say greater than or equal to 7, 8 is also covered. 8 is also covered. Now you are left with only 4. So all those cases are covered, no? Greater than or equal to 7 means what? 7 is covered, 8 is covered, 9 is covered, all are covered, right? Yeah? Greater than or equal to 7. It is not equal to 7. I didn't put it equal to 7. Greater than or equal to. Therefore, again the sign comes here is greater than or equal to 0. Okay? I hope it's clear now. Yeah. It's greater than or equal to. Read that sign. It's greater than or equal to. Good. Yeah. All cases are covered. All of them are covered. Good. All right. Here we go. Try this question now. Try this question and plug the answer in your own terms. You can give the answer as NCR minus MCX, something like that. I'll let know whichever way. In that format also is fine. But give me the answer. If you have understood what I did, how to deal with the upper limit, deal with this question. You don't have to simplify the values. You can give the values as total minus unfavorable. Give me the answers in terms of total minus unfavorable. Simplification can be done in the exam. They might expect us to simplify there. So for now, you give me total minus unfavorable. It's easy for me to understand that you are writing the right numbers. Just put something like NCR. Don't worry about the positions of NCR. Just write it as a number. Go ahead, plug the numbers. Yeah. Take another minute. Write these numbers. Yeah, others put it. Sahil, put the number there. Why are you taking so long? It's becoming difficult to type. Yeah, good, good. All right. So now it has 4 wagons. Let me call it as the number of packs that will go into first wagon, the second wagon, third wagon, and fourth wagon. How many bags? 48 bags. 48 bags get into these 4 wagons. So this is what I need to do. So, but each wagon has a limit. Already each wagon has a limit of what? Each wagon has a limit of 25 bags. So that is 0 to 25. You can give from 0 to 25. But we told the method, don't worry about the upper limit. First, simply go with the lower limit. Simply go with the lower limit. When you go with the lower limit, it is also possible that 48, 0, 0, 0 is a solution, which is an absurd solution. Of course, it's an absurd solution. But when you don't consider the upper limit, this mistake might have happened. Fair enough. All right, that's a total. But then nevertheless, that's a total. Yeah, what is the total? Therefore, 48. We already know how to write this, so that should not be a problem. So this total, this answer to this is nothing but 51C3. All right, that is the answer. That's a total. 51C3 is the total, but there are absurd cases in this total as well. As I just told you, it is quite possible that you might have tried to load all 48 into one, which is not possible because the upper limit is 25 bags. You can't load more than 25 bags of coal into a particular wagon. So now you come to one of them, target wagon 1. Say that wagon 1. So what are the unfavorable cases? Wagon 1 taking 26 or more. All right, wagon 1 is an example. You may say that wagon 2 I will take it. It doesn't matter. You have to permute across the wagons. This overloading might have happened in any of the wagons for that matter. But take wagon 1 as an example. The wagon 1, if all the cases in which wagon 1 has taken more than 26 bags are unfavorable, that is not, that cannot be accommodated technically, because 25 is the upper limit. So what about the others? Others are still at zeros. Others would be still at zeros. That's what you are trying to say. Good. So remove these cases of 26. Remove these. You may say that, sir, what if 2 wagons have this greater than or equal to 26? Not possible, because the number is 48. If 2 wagons have 26, then you have to subtract the numbers from the other wagons, right? So that's what it technically means, because 26 plus 26 is 52. But I have only 48 bags here. So 2 wagons wouldn't have been overloaded. If the overloading would have happened, it would have happened in only one of the wagons, right? It could have happened in only one of the wagons. So, and hence you say, okay, so now coming back to this, I will rewrite this particular equation. Wagon 1, so I will bring it down to greater than or 0 condition. Wagon 2, wagon 3, and wagon 4, right? Yeah, wagon 4. I will bring it back to this particular condition by subtracting 26 bags. So which will become 22 bags. All right, 22 bags, and hence you write the answer to this particular equation as 25C3. These are the unfavorable cases, but this unfavorable is taking W1 as an example. This can happen with any of the 4 wagons. It can be with wagon 2, can be with wagon 3, wagon 4. Any of this could have got overloaded. Therefore, these are the unfavorable cases. 25C3 into 4. This is the required answer. Of course, in the exam, I might expect us to simplify this and answer this, but this is what it is. Yes. Okay, this is Sahil. What you are trying to say? I've taken the greater than or equal to 1 in the first case. No, why it should be greater than or equal to 1? Your wish. Where it is written that every wagon should have at least 1 bag loaded. You are adding a condition, Sahil. If you are writing 1 here, alright, if you are changing it to 1, for example, say, alright, no, so you are saying that I am changing these numbers to 1, then you are adding a condition to yourself by saying that every wagon should carry at least 1 bag. Where it is written? Clear? Don't add conditions. Nowhere it is written that every wagon should be loaded with at least 1 bag. There is no such condition, right? You don't add conditions. We will go by what is given, right? If that statement is given, sure, I'd have changed all these zeros to ones. We'd have changed all those zeros to ones. If every wagon should carry at least 1 bag. Okay, good, very good. So that's how you kind of deal with upper limit. I am sure those who are prepared for IIT, JEE, etc., upper limit can be possible with 2 wagons as well. Change this 48 to 60. All right, just for example, I'm not going to teach this now, so I'm not going to teach this, and I'm just telling that, hey, what if I change this upper limit to 60? Then two of the wagons could have been overloaded. Why only one wagon? Two of the wagons can be overloaded because it can take only 25 bags. Now, this is dealt by using the principle of inclusion exclusion. All right, principle of inclusion exclusion, which you technically study in the 11th standard, provided you are preparing for some of the engineering entrance exams at the level of IIEEE or IIT JEE, etc. Right? That is what you could have kind of done that, right? Okay. No, Rishabh, that is not the answer. That is not the answer. First, you have to apply the principle of inclusion exclusion, and then you will do that. And then you will do that. The method itself would change. We will see it if it is required. We will see it for that preparation. Okay. We'll see it for that preparation. Very rarely such questions have come. If you look at all the last 10 years papers of CAT, ZAT and IIFT, you might find one question. So let's not bother too much about one question. Fair enough? That's a good deal. One question in a decade across 3 exams, right? That is in 30 papers. 30 QA sections, you will get one question. So let's not worry about that. That probability is very, very minuscule. So such probability, such question, sure, we will take it up at a later stage. I'm not denying it. We will take it up at a later stage if there is a time. Let's go with little better probability. That's my question. Whenever we select a concept, let's assume that the probability is better across 3 exams at least. Right? Let's not go with such probability of one question in 30 exams, not 30 questions, 30 exams. That's what we are talking about, right? Yeah. Okay. Great. All right. So let's, okay, answer this, guys. Let's start with this. Let's start with this. Then it tells me the story that how much of background I should give. Yeah. Take a minute. Try and see how you go about answering this question. This is a CAT question as it is. This is the CAT question as it is. I have not changed any data, including answer options. It is as it is. You can write the answers in terms of NCR itself. Fine, let's go to the basics. All right, let's quickly deal with the basics for 5 minutes. Maybe that could help, right? Let's go to the basics and deal with it for 5 minutes. Probably that will help you to address this particular question better. All right, this question better. Let's understand. Let me take a smaller diagram which can be dealt with. All right, which can be dealt with. Okay, let me take this. So then we'll come back to this CAT question. After that, decagon also had come in the picture, right? So in one of the exams it is octagon. So in one of the CAT papers it is octagon. In one of the IIFT papers it was decagon. Somewhere here it will become another gon. All right, now this is what keeps happening. That's not a big deal. So let them keep changing the diagram. So number of polygons they keep changing, but method remains same. Okay, let's come to the basic part of it. Let's understand the basic. Quickly understand this, then we'll go back to that CAT question and solve, and maybe we'll extend to few more concepts after that. Find the number of triangles that can be formed. Take a look at this question. Number of triangles that can be formed by using the vertices of a regular hexagon as the vertices of a triangle. So these are the vertices. A is a vertices, B is a vertices, C is a vertices, D, E, F. These are the vertices. I am saying that, hey, form triangles. All right, you have to form triangles by using these points itself. You don't create another point here called as G or something. No, you can't create. That's what the author is trying to say. Okay, such that conditions. 3 questions, one at a time. First question, such that 2 sides of a triangle also the sides of the hexagon. Let me call it all 2 sides. Let me do the first question. You have to use these vertices only. You are not supposed to use these vertices. At the same time, author is also trying to say another condition, 2 sides of a triangle also sides of the hexagon. Let's use that question. What do you mean? Hey, use this. Let me call this side something like this. Let me call this side as P. Let me call this side as Q, R, S, T, U. These are the name of the sites. Say, what are these P, Q, R, S, T, U? These are not points. These are the names of the sites. What I'm trying to say is, hey, take these 2 sides P and Q and close it. That becomes a triangle. Take 2 adjacent sides P and Q. Take P and Q, 2 adjacent sides, and close it. Close it. It forms a triangle. You may say that, no, sir, I will take another 2 sides. Okay, take Q and R. Take Q and R and close it. So now this is where you mean that, hey, you are using the vertices of the hexagon as the vertices of the triangle, and also you are using two of the sides, and also you are using two of the sides. Two conditions. Hey, what is one condition? The vertices of the triangle, vertices of the regular hexagon should match with the triangle, should also vertices of the triangle. At the same time, we are also saying that two sides of the triangle should be common. So I am using the same three vertices, 3 points are required to form a triangle. At the same time, I am also using the two sides. You may say that no sir, I will use some other part. Sure, you can use U and T, two adjacent sides, and then close it. Which vertices did you use? You use the vertices called as A, E, F. So but you have to use two adjacent vertices, adjacent sides only. For example, you can't say that sir, I will use this side called as R and I will use this side called as U. I will use two sides. No, you can't use these two sides and form a triangle. You got to be using two adjacent sides as well. What are possibilities then? PQ is adjacent. QR you can use, two sides Q and R you can use, or R and S you can use, or S and T you can use, T and U you can use and close it, or U and P you can use to close it. Now you are trying to say that 6 triangles can be formed. Hey, what is the meaning of this? Pretty simple. If it is a n-sided polygon, if the given polygon is an n-sided polygon, in an n-sided polygon, if two sides of the triangle are also sides of the hexagon, such triangles are going to be n. You can form n such triangles. Okay, any confusion on this n? This n generalization is clear? Is this n generalization clear? It's always going to be n. If it is a decagon, 10. There will be 10 triangles in which two sides of the triangle match with two sides of the decagon. Is this n clear? Is this n clear? Quickly. N clear? Good. Very good. All right. Now let me go to the second one. Let me address the second one. Listen to me, guys. Listen to me. Listen to me, because there are 3 parts. There are 3 parts here. Second one. Let me now go to the second one. Exactly one side of the triangle, also the side of the hexagon. Now listen to me. Let's say that, hey, this side I am taking this. This side is common. This side of the hexagon, when I take this side of the hexagon, is common with the triangle, which means I have chosen point C and D, which implies you can't choose point E and you can't choose point B. You can choose point A, then you form this triangle. Then you can form this triangle, or you can choose the point F so that you can form this triangle where one side is common. Which side is common? The side CD is common. The side CD is common. I can form 2 triangles where one side is common and 3 vertices of the hexagon I'm using. I can form 2. Now you may say that, no, so what if I use this particular side common? Which side you want it to be common? Let's say that I want to make BC side common. BC is one side which is common between triangle as well as hexagon. Fair enough. So if you have chosen BC side, which means B and C are chosen, you can't choose B and C as the third point. Also, you can't choose point A and D as the third point. You can choose point F. You can choose point F. This is the triangle you are saying. That is ABC is the triangle. FBC is the triangle in which BC is the common side. Or you may say that no, I will choose point E. Then you are saying that BEC is the triangle in which one side of the triangle is common with the hexagon. So what is that you are trying to say? You are trying to say that, hey, you choose the base in n ways. This base can be chosen in n ways. Why n ways? Because it's a 6-sided triangle. You can either choose the side 1 as the base, which means common side, or you can choose side 2 as the common side, or side 3, which means you are trying to say that I can choose the base, common base in n ways. On each base, I can choose the third vertices in n-4 ways. You may wonder, what is this n-4? Let me illustrate this once again. Let's say this, the base is CD. CD is the base. CD is the base. Now this is the point. n-4 is the point. So now the third point. This is the third point. Third point, where I'm choosing my third point, I cannot choose C. I cannot choose D because CD is already base, which means point C has been already selected. Point D has already been selected. You can't say that I will select it once more and form a triangle. No. Along with this, you cannot choose the point E. You cannot choose the point B. Now these are the 4 points you cannot select. That is n-4. Hey, there were n points here. In this case, there were 6 points. In this case, there were 6 points. Out of this, when you are trying to select your third vertices, you cannot select C, you cannot select D, you cannot select E, and you cannot select B. You can select A and close it, or you can select F and close it. What if it is a decagon? You can't select these 4 points, you can select any other points. In the sense, you can take CD as the base and you would have formed 2 triangles. At the same time, you may say that no sir, now I will take DE as the base. Again, you can form 4 triangles, and hence this N stands for selection of the base. The base can be selected in n ways. On every base, the third point the moment you select a base, 2 points get selected. The third point can be selected in n minus 4 ways. Is this clear to you? N times of n minus 4 is clear. Is this n times of n minus 4 is clear? First, you have to select the base, which is common between triangle and hexagon. And then you choose the third point. That is what you mean by one side common. That is what we mean by one side common, right? Very good. Okay, now the last point, no side common. No side common. Let me show you here. There are only 2 such triangles here. No side common. There are only 2 such triangles. If I select A, I can't select B. Because if I select B, then the side will be common, right? I can't select B. If I select A, I can't select F. I can't select F. Then AF would become a common side. I can't select the point F. Then I have to select. I can't select D as well. B is anyway not selected. Now I can't select D as well. Therefore, you say that I may have to select E. Now this is one triangle. AEC is a triangle which has been formed by using the vertices of the hexagon. At the same time, no side of the triangle is common to the hexagon. That is one. Second one is, hey, I can use this F and B and a D. This is another triangle, the green one. Now look at this. I am using these 3 points, that is ABD. But at the same time, all right, I'm using three vertices, but no side is common between them. The answer is actually 2. Here it is easy, but how to do this? No side of a triangle is common. How to do this? Now look at this. Now this is in fact the classification of the total number of triangles. If there are 6 vertices, listen carefully, my friends. If there are 6 vertices, total number of triangles can be formed. Total triangle 6. Why 6 vertices? Because the given diagram is a hexagon. In this diagram I'm talking about, in a hexagon, total triangles that can be formed are 6C3. Why 6C3? I need 3 vertices out of 6 vertices and then join them. You get the total number of triangles. What is this value? 20. You are trying to say that 20 triangles can be formed. Now classification. Out of these 20 triangles, case 1, 2 sides will be common. 2 sides common. 2 sides common. 2 sides common. 2 sides common are nothing but n. In our case, we called it as 6. Why? Because it's an n-sided diagram. N is equal to 6. So that's 6. All right, out of this, there are 6 triangles. Out of this 20, 6 triangles will have 2 sides common. That's what we talked about. Case 2, one side common. What do you mean by one side common? One side is common to triangle as well as to hexagon. Exactly one side common. Okay. We said that one side common is base can be selected in n ways. The third vertices can be selected in n minus 4 ways. In this case, the value of n is 6 and the value of 4 is nothing. Value of n minus 4 is nothing but 2. 12 such triangles can be formed. Out of 20, there are 12 such triangles as well. Therefore, case 3, when you are writing case 3 is total minus case 1 minus case 2. That is the way to write the case 3. What is the total here? Total here is 20 triangles. What is the answer to the case 1? 6 triangles. What is the answer to the case 2? 12 triangles. Subtract them, you get the value for the case 3. Alright, therefore case 3 is nothing but 2 triangles. This is the way to find it. There is no direct way to find the answer for case 3. Is the case 3 clear to all of you? You understood this whole summary story? Story is clear? Is this story clear? It is very important. Generally, as far as I have seen, only this case 3 is asked in the exam. Case 1 and case 2 are never asked in the exam. Generally, case 3 is what is asked in the exam. Clear about this? Case 3 is clear. Because there cannot be case 4. There can't be case 4. There can't be case 4. You may say that, sir, why case 3 should be total minus case 1 minus case 2? Because only 3 cases. What are the 3 cases? 2 sides common, 1 side common. Case 3 is what? No side common. All right, if you want to write that, what is case 3? Case 3 is no side common. You can't say that, sir, I will have another case called case 4 in which 3 sides common. Hey, how 3 sides of a hexagon will be common to 3 sides of a triangle? Not possible. You can't say that I will take this side and this side common. Hey, is this called as a triangle? No. All right, 3 sides cannot be common. 2 sides common is possible. 1 side common is possible. No side common is possible. If I am writing no side common, that's all the possibility here. Therefore, no side common is nothing but total minus case 1, that is 2 side common, minus case 2, all right, which is 1 side common. This is the way to approach this particular question. Let's come back to one of the CAT questions. Now let's come back to the CAT question. How to go about this? Octagon. Octagon means what? N is equal to 8. It's an 8-sided figure. So now therefore you say that, hey, what is that? No side. None of the sides are common. You are forming the triangles in which none of the sides are common. How do we do this? Therefore you say that first let me find all possible triangles that can be formed minus 2 sides common. That is one of the cases. 2 sides common. 2 sides common minus 1 side common. 1 side common is equal to no side common, is equal to no side common. That is the way to arrive at this. Okay, what is total? Total number of triangles. Octagon means 8 sides. 8C3, that is the total, minus 2 sides common. 2 sides common is going to be n. We talked about this. Hey, this is what? NC3, that is the total. 2 sides common is n. 1 side common is n times of n minus 4. So let's write that. 2 sides common 8. 1 side common, therefore 8 times of 8 minus 4, which is nothing but 4, which is nothing but my answer. Okay, figure out this answer quickly. Find this answer. Find this. What is the answer here? This is how we got to answer this question. Fast, my friends. Quick. What's the answer here? Only Rishav got the answer. Others, only Rishav got the answer. Sahil, anybody else? That's right. This is 56. Absolutely. 56 minus 8 minus 32. Answer 16. That's correct. That's correct. Okay. Now let me ask you a question. How many diagonals are there in the hexagon? How many diagonals are there in the octagon? Let me ask a question, okay, on this. So I'm just asking a question here. How many diagonal lines are there in an octagon? Answer, go ahead. Whoever is answering this quickly. How many diagonal lines are there in the octagon? Very good, right. Number of diagonal lines are nothing but 8 vertices are there. The number of diagonal lines, right? How do we find the number of diagonals? We find there are octagon was my example. Octagon means I have given 8 points. I'm given 8 points. Total number of straight lines are 8C2. That is the total number of straight lines minus 8 boundary lines. These are total lines. If there are 8 points, there will be 8 boundary lines. Rest of them are diagonal lines. That is right. 8C2 minus 8 is the number of diagonal lines. Okay. Yeah. Good. All right. Hi Uttam. Hello. Yeah. Okay. Next question. What can be the maximum number of, this is one of the questions, one of the CAT questions. What could be the maximum number of points of intersection? Okay. Let me write it here. Let me put it out here. I think I formed it. Yeah. Okay. Answer this question. Yeah, good Uttam, good to have you here. Yeah. Answer this, Risha, Uttam, Sahil, whoever else is there in the meeting, answer this. Find the maximum number of points of intersection of diagonal lines that can be formed by using the vertices of a convex hexagon. Points of intersection of diagonal lines. Kunal says 7. Rishabh says 3 par 6. Such a big number, Rishabh. So many points. Find the maximum number of points of intersection. Say for example, okay, now take a look at this. A, F, E, D. Let's assume that, okay. Now this is the point. Now this is one point of intersection when these four diagonals meet. All right, when these four diagonals meet, not four diagonals, I mean these 4 points. Take 4 points, only 2 diagonals can be constructed. That's it. Now listen carefully. All of you listen carefully, guys. Listen carefully. When you take these 4 points, use in isolation A, F, E and D. Take these 4 points. Take any 4 points. Take any 4 points. It doesn't matter. Take any 4 points. Only 2 diagonals can be formed. When you take these 4 specific points, so 4 points, only 2 diagonals can be formed. Many straight lines can be formed. You have to take the alternate ones you should join. A must be joined with E and F should be joined with D. That is the only way. You can't say that, sir, I will join this with this. Okay, this with this, then you will end up joining F with E. What is the use there? All it cannot be. Therefore, if the diagonals, if I had used the points A, F, E and D, listen carefully. So one of that, where is the point of intersection of a diagonal come? The diagonal going from A to E, when intersects with the diagonal going from E to D, I get one particular point. Now let me take another example. Okay, I will choose another 4 points, let's say. So A, F, E and D. Had I taken these 4 particular points, which diagonals I'm talking about? Many lines can be drawn by using these 4 points, but which is the diagonal intersection I'm talking with? B would have gone to E and E would have come to D. Now I'm talking about the intersection of these 2 diagonals, which means what is the point I'm trying to say? Look, all right, now you first select 4 points on your geometry. They form only, there will be one point of intersection for every 4 points, 4 vertices that you select. For every 4 vertices that you select, there will be only one point where they are going to intersect. Hey, did you get this concept, guys? Did you get this concept? Is this clear? Is this clear? You select any 4 points. There is only one meeting point of those diagonals, because technically 2 diagonals will come in the 2 active diagonals will come in the picture. Many diagonals can be drawn. Hey, when I select these 4 points, listen once again, all of you. When I select these 4 points, many diagonals can be drawn. This is the diagonal. This is the diagonal. This is the diagonal. This is the diagonal. Correct. Many diagonals can be formed. But the point is, hey, this is the only point of intersection you got. Listen, all right, that is my point here. You get only one point of intersection. The other diagonals don't intersect. The other diagonals don't intersect. There's only one intersection that you get. That's it. There is only one intersection. Clear about this? Clear about this? Any 4 points, Srishti, any 4 points you can take. Give a quick confirmation that you understood. Active diagonals I'm talking about. Understood, Rishabh. I got your point. No, all will not. There are active diagonals. Some of the diagonals becomes passive. Passive from the perspective of our perspective. Passive from our perspective. It's still a diagonal, right? B to F is still a diagonal, but it doesn't contribute for the cause. It doesn't contribute for my question. It doesn't contribute for my question. That's the point I'm trying to make. Okay, good. So therefore, now tell me, what is the answer here? For this particular question, what is the answer? The question that you are seeing, what's the answer? What's the answer to the given question now? You got the concept. I explained the concept. I explained the concept. What is the answer? Good. Very good. 6C4. Because I have 6 points. Select any 4 points. Select any 4 points. You select any 4 point, you get only one intersection. Select any 4 points. Therefore, 6C4. If it has been a decagon instead of a hexagon, had I changed this particular word to decagon, which was one of the exam question, right? One of the CAT question, CAT-ZAT, I don't remember. One of those questions. Had it been a decagon, answer is 10C4. Answer becomes 10C4. Hey, did you get this point? Yes or no? Everyone, did you get this point? Did you get this point? The active diagonal part, did you get it? There are many diagonals, but point of intersection is contributed by certain designated active diagonals in each case. Did you get that? Yeah. Good. Yeah, that's a little bit of a story around these triangles and diagonals, right? Yeah. So yes, surely, all right, we will continue this particular study. Two concepts we learned. We learned about how to go about the upper limit. That was one of the concepts, right? And then we kind of learned about the second concept that we learned is how to deal with the triangles in which no side is common, etc., etc. If you have liked the video, click the like button, share it with others, subscribe to these videos so that you get a notification whenever I schedule the lecture. Sure, all right, we'll continue here. Sunday, all right, now tomorrow being a Sunday, guys, all of you write the mock. All of you write the mock. You can in fact take the mock, free mocks that has been given for 4 weekends by Unacademy as well. You can take this. That's at 12:30, right? 12:30 p.m. Take that particular mock, and you can park some of the mocks that you are already taking, reserve it for some other day, right? Yeah. So if you have liked it, say any content, you do that part, and then yes, so you can join me if anybody is on the plus subscription. One of you are saying that you are on there, so you can join me here for IIFT lecture starting at 7 p.m. 1 hour we'll spend on that. So I'm doing the algebra module specifically for IIFT. You will understand that how practically they ask certain questions. Beautiful questions are asked in IIFT based on that particular concept. I'm starting with the equations today. I'm starting with some of the equations. 2 days I will cover this. You can join me. Those who have the plus subscription, yeah, you can join me at 7 p.m. So I will cover some of this particular theme in the coming days. Yeah, that's pretty much. So you have any of your concerns, quickly let me know. Thanks, Rishabh. Thanks for that comment. Yeah, thanks for the comment. Wonderful, wonderful. Yeah. So guys, Sunday, please everybody write a mock. Otherwise, don't attend my lecture on Monday. Write a mock on Sunday. Yeah, on a lighter note, I'm saying I'm pretty serious at the same time as well. Okay, if you don't attend the mock on Sundays, no point attending lecture on Mondays. Yeah. Yeah, it is Rishabh, but that's a low scoring paper. At the same time, you understand that IFT is a low scoring paper. You have to get your approaches right. That's it. You got to get your selections right, approach right. Yeah, that's what happens. Yeah. Great. Any questions? Anyone? Any questions? Otherwise, I will call off the time. I will see you guys maybe on Monday, or if you are on the plus, I will see you at 7 p.m. maybe in about 1.5 2 hours time. You can have a cup of coffee or tea and you can join me out there. Great. Even if you're watching it offline, so you can put your comments in the comment section of the video. You can put that comment section. And yes, you can join this particular Telegram group for some notifications or whatever the quick discussions. You can always join in there. All right, that's pretty much about it. I'm closing the meeting then. So I will see you guys in a couple of hours time or on Monday. Bye till then. Stay blessed. God bless you. Stay blessed.